Okay, hello guys. Wait, my mouse is not working. We're just waiting for one more person. I think Ryan's coming. Okay, Ryan is coming very soon. Just to be sure, wait, I believe you guys can see the screen right now, right?
Yeah.
Okay, I'm just gonna use the textbook to teach today. So yeah, we'll wait for Ryan for a bit. Yeah, before he comes, today we're gonna do exponentials and I think all of you have done some exponentials before, okay? So when we speak of exponentials, we really mean this letter E. This is too complicated, and you guys don't need to know what it is right now. Right now, we're just basically focusing on stuff like this. We're just focusing on formulas like this, and this, okay? Is it clear enough, or do I have to zoom in?
No,
Okay. Do I have to zoom in, or is okay? You guys can see everything?
it's okay.
Okay. All right. So I believe both of you have done exponentials with me. So I'm just gonna quickly revise these formulas and then we will move on to the questions. So the first one is this. So if you have AM times AN is M plus N, and the logic behind that is exactly here, right? So the power means a bunch of stuff, a number of x's multiplying each other here, right? 6x multiplying each other. And the x squared is 2x multiplying each other. So altogether, we have 8x multiplying each other. That's why the power adds. Okay? So this is quite intuitive. You could just think about you have a lot of things multiplying each other, and you can add the power. Okay?
Yeah.
And then next one is the same thing, but divide. Okay? So if you have a bunch of x multiplying each other, divided by a bunch of x multiplying each other, these will cancel out, right? And that is why the power subtracts, right? 6 divided by 2, the power subtracts. And you may wonder, what if this 2 is bigger? What if we have something like x to the power of 2 divided by x to the power of 4? This is actually x to the power of negative 2, sorry. Okay? By the formula, this is x to the power of negative 2. But by this fraction, we also know this is 1 over x squared, which is x negative 2. This brings us to one more formula, uh, which is this. If you have a negative power, it is the same as this is the same as 1 over that positive power, which is what we just had. We had x to the power of negative 2 equals 1 over x squared. Okay?
Yep.
All right. Hello, Ryan.
Yo,
We just started, so I'm just gonna go through this formula quickly with you. Do you know this one?
yeah,
Okay. Do you know the subtraction? The divide becomes subtraction.
yeah,
And then do you know this one? The negative power becomes this
yeah,
fraction.
I know that. I know
Okay,
that.
sweet. Do you know the reasons behind it?
No.
Okay. I'm just gonna quick. Oh, the first two, do you know
Yeah.
the reasons behind them?
Oh, no.
The first one, okay, look, we have a bunch of x multiplying each other, a bunch of x multiplying each other. It's a bunch of x multiplying each other, so the power
Mm.
adds,
Yeah.
obviously, right? That's just the reason. The second one is the same. It's
Mm-hmm.
a fraction, so some of them cancel out, so it's subtract.
Yeah.
And just as I was saying to Hannah and Adriana, when we have two power, what if the top power is like 2, the bottom power is 4? So the top one's greater than the bottom one. So we know this by the fraction, we know this is 1 over x squared, right?
Mm.
By dividing top and bottom by x squared simultaneously. But by the formula here, this is also 2 minus 4. So x2 minus 4, which is x to the power of negative 2. Okay?
Mm-hmm.
So it's obvious that this equals to this. And that's
Yeah.
what negative power means. And that's where the negative power formula comes from.
Yep.
Okay. And that's the reason behind this formula here.
Mm-hmm.
Right. And anything to the power of 0 is 1. There are many ways to remember this. One way is to think about you are subtracting the power to 0. So you're doing something like this. But it's just pretty intuitive to have something to the power of 0 is 1. Because when you do polynomials and stuff, you have x squared times the constant. You have ax squared plus bx 1, bx plus c, right? You can treat this as x1 and x0 here. If you think about x0, if this is not 1, this term will disappear. So it's obvious that this equals 1. And that's why the c is still there. Okay? There are just many ways to think about this. Yeah, anything to the power of 0 is 1, including 0 to the power of 0. This equals 1. Okay? Any questions? No questions? Cool. And we move on to some practices. Yeah, this practice might be a little bit hard, but here, 9A, do 9A. So well, I guess we start from 1 all the way to 2, 3, 4, 5. We'll see how we do. Okay, send me the answer when you get the answer. Send me the answer in the chat.
Wait, just 9?
9A. So
Oh,
this whole exercise.
okay.
Oh, what?
Yeah,
No.
yeah, 9A. Just do them one by one and then. Okay, Hannah, that is correct. Hannah, that is correct. Adriana, that is correct, but not a capital letter. Oh, to represent power, you use something like this. Okay, let's say you have x squared. You write this to indicate x squared. Or if you have a lot of stuff, bracket squared, or like to the power, you do something like this. Okay, I've typed out some examples in the chat. Hannah, that is correct. Ryan, how are you doing with the first one?
You want me to send them all as in like,
Oh, up to you. Like you
oh,
can send them one by one or like all together, but like up to you.
I'll just send it all together.
Yep. Ah, guys, I had a really bad news. So I was fidgeting with my pen. There's like this tip that I can take out. I like took it out and I lost it. So I can't really use my pen right now.
Damn.
Oh my God. Give me like a few minutes. I'll try to find it. Oh, why am I doing this? So like my writing pad is the electric one. It's like the tip of the Apple pen, but oh, I found it. Nice. Okay, sweet. So it's like this little tip, and I lost it. All right, let me go back to the question. Adriana, that is. Nope, Adriana, that's incorrect. for your second question. For question 2, that's incorrect. If it's correct, please just move on. Hannah, that is correct for 4. And then, oh, Hannah, that's incorrect for 5. Close, but incorrect for 5. And then for 6, Hannah, that's incorrect for 6 as well. Okay, Adriana, that's incorrect for 3 and 4. Oh, 4 is correct. Okay, that was a typo. Okay, Hannah. Hannah, that's incorrect for 7. Like, it's mostly correct, but it's just like some tiny mistakes, but those matters. Oh, wait a second. Oh, I'm sorry. I think, yeah, I think I was typing too. Yeah, ignore my typing. I think I forgot to message. Yeah, if I say it's incorrect, just do it again. Maybe write it down on paper as well, so when I actually explain it, you guys know if it's correct or not. Hannah, I don't know which question is this. The last one? The last one is the last one is X term correct, Y term not correct. The X14 is correct. The Y6 is not correct, Hannah. Adriana, you? Okay, that's 5. Adriana, no, that's not. Oh, wait a second. Why are you typing a V on the next line? You're typing a V. You're typing answer of the same question in 2 different lines.
Yeah, my bad. I like click send.
Oh my God, type it properly. I can't read what it means. I don't even know where the V is supposed to go. Okay, the second one was correct.
Wait, Michael, have you checked my answers yet? Or are they like too hard to
Oh yeah,
read?
sorry, no, I'm just busy with checking everyone's answer. Yeah, I saw your answer, but I didn't check it once. Yeah, I'm doing it right now. Hannah, this one is 14. Which one is this? Oh, that's question 2. Yes, Hannah, I believe that's correct. I thought you get this one correct. I thought you got that correct ages ago. Did you not?
I don't know. You typed it to me.
Oh, you said. Oh, that was weird. You know, you got that one correct ages ago, but
What?
I quoted to you the wrong Adriana's answer, but I don't know why the system sent it to you, so it was like a mistake. So just
Wait,
listen
so
to what
which
I
one
say.
am I? Which one?
Your question 2 is correct. This
Okay.
is correct. All right. I think next time we'll probably don't do not do it like this because this is like an easy set of questions, but it's too hard for me to mark everyone else. So I guess next time we'll do something like you guys write down all the answers. If you're unsure, you can ask me, but I'll explain all the answers in the end. Does that sound good? Otherwise, it can get too messy. Or do you guys have any suggestions? All right, I guess I'll just explain the questions. All right, so the first one's easy. It's just simple first formula application, right? You add the powers. This is a to the power of 5 plus 3 plus 7, which is 15. Okay. And the second one is slightly harder, but it's just a bunch of stuff multiplying each other. And we can shift numbers around. So we can do the 2 times 7 first, which is 14. And we can do this first, which is x7. And then we can do the y last, which is y8. Okay. Since all of them are multiplying each other, so we can shift the orders around. I guess that's pretty obvious. And the third one is the same thing. You look at the two numbers first. This is 2, and then A7BC, which is the answer. I guess it's much easier for me to write it down. Yeah, guys. Okay, from right now, please just check against my answer. If there's any mistakes, you can just tell me, and then I can wait for you to like, because it's too hard for me to check everyone's answer and then like try to get back to them. I can say if it's correct or not, but yeah, it's hard for me to keep track. So yeah, as I'm explaining, if there's any questions, just interrupt me and stop me, and then we can have a look. Otherwise, I'm going to move on to question 4. So any questions up to now?
Wait, what happened to the B?
Oh, sorry. I think I asked B cube C. I think I accidentally rub it out. Yeah, that's correct.
Mm-hmm.
Okay, and we look at 4. It's a division. So technically, we could do something like this. We could split it up like this, right? Technically, we could make it like this, and then this becomes 2m squared. Okay. This is the formula we use, the subtraction formula we use. Okay. And then for 5, we do the same thing. 6/9 can be simplified. These are the only number in this equation. So this simplifies down to 2/3. And then here, look at u. So technically what I'm doing is I'm splitting this up to this times u5/u3 times v squared over v3. And that becomes much easier. That becomes 2/3 times u squared times 1/v. And put it together in one fraction, we get 2u squared over 3v, right?
Wait,
Any,
Michael, do you have a
yep,
v to the power of -1 on the top?
yes, you can. That's the same thing.
Yeah.
But here, I believe, I don't think it wants you to have negative power. It depends. Sometimes the question wants you to have negative power instead of fraction.
Yeah.
Sometimes the question wants you to have fraction rather than negative power. But in this case, since you already have a fraction 2/3, might as well have a fraction. But if this is the actual exam, writing this wouldn't be wrong. It'll be fine.
Yeah.
Okay. Good question. Good question. Give me 1 second. All right, it's a bit messy. So I'm just gonna delete everything. Any questions up to question 5 right now?
With number 4, isn't
Yep.
it 2m2? Like,
Nice, nice. Yes, it is. It is. Sorry, my bad. Yes, 2m squared. I believe I said 2m squared. Maybe I rub it out, or I just said something or wrote something different. But yes, you are correct. Any other questions? No? Okay. Thank you for that, Adriana. Yeah, sometimes I make mistakes. That's the problem. So please, if you see something weird or don't understand, just always ask me. It might be like you misunderstanding something, or maybe me making a mistake. So yeah. Question 6. This is kind of weird. We actually haven't done this. So if we have like a b to the power of c, this is actually a to the power of c times b to the power of c. The reason behind is pretty intuitive as well, because if you think about this, this is pretty much a bunch of A, B, A, B, A, B multiplying each other, right? A, B times A, B times A, B times A, B, dot, 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 dot. And if you can rearrange them to be A times A times A, dot, 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 B times B times B, dot, 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 all the way. Okay? So that's why we can, and you group this into A to the C and B to the C. And that's why this formula works. And for question 6, we gotta use that. So instantly it becomes 3 to the power of 3, r to the power of 3, and s to the power of 9. Okay. And then that becomes 27 r3 s9. Okay. Okay, Ryan, you got that one correct. And then I believe Hannah or Adriana, one of you wrote 9. Oh yeah, Hannah, you wrote 9 instead of 27. Okay,
Wait, correct for 10 or 6?
6.
Oh,
I'm just doing I can't be bothered. Like it's not can't be bothered. It's too much effort checking everyone. There's too many questions. But if you have any question, you can ask. You can ask me. For question 7, it's the same thing. But here, the only thing different is the -2. So if you take out -2, right? This negative sign actually stays because a power of 3 does not cancel the negative sign. And everything else is the same. X to the power 4 to the power of 3. This is, we haven't introduced this as well, but I believe that's pretty intuitive. If we have x to the power 4 to the power of 3, this is x to the power of 12. Okay, we multiply the power. So in this case, when we bring the 3 in, this is multiply. And -2 to the power of 3, if you think about it, -2 times -2 times -2. The first two gives you +4. But +4 times -2, this is -8. Okay. So you get -8x 12 y3 z15 for the answer of this one. Does that make sense? Because I feel that one could be a little bit hard, so I want to make sure everyone gets it. Adriana, Hannah, does that make sense?
Yeah.
Hannah?
Mm-hmm.
Okay, cool. Nice, 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 nice. Okay, and then we have the last one. I think for 8, 9, 10, I'll let you guys do it and I'll check the answer. Because 3 questions wouldn't be as messy. So send me the answer of 8, 9, 10. If you have sent it to me, just send it to me again now. I believe, okay. Ryan, that is correct for your last. Yeah. Adriana, that is dodgy, but correct. You should have a power, like power sign and lowercase y, but okay. Ryan, that looks very sus. Why do you have 1 over x -7?
because it's a negative. Oh, so it's my bad. It's meant to be a positive. They're meant to be positive since they're over.
Yeah, no, I haven't checked the question, but like just looking at the answer is really weird. All right, Hannah, that is unfortunately incorrect. I'll give you like 1 more minute. Everyone else can move on to 9. Yeah. Hannah, that is close, but not correct.
New
Oh,
answer for 9.
yeah, I'm checking 9 right now. Give me 1 second. Okay, Ryan, I see. If you're doing 1 over, you should add a bracket because technically you say A over BC. This is the same as A divided by B times C, right?
Oh,
So technically you should add a bracket. I get what you mean, but to be precise, you should do that. But A over B times C
bracket
is pretty much this.
to the X or like what?
Just the bottom part like this. Do you see the screen?
Oh, the bottom part, my bad. Yeah.
Yeah, yeah. This is a very famous answer. Hannah, that's correct. Okay, move on to question 9. In the meantime, I should tell you guys a funny thing. This is a famous thing on Instagram. A lot of people are debating whether like wait, let me think about the actual question. I can't remember the actual question.
Wait, Michael, do we need to do 11 or and 12?
No, just do 8 and 9 and 10. I will, yeah.
Wait, I thought I already sent you the answers for those.
Oh, yeah, yeah. Yes. Let me check 10. Okay, Adriana, that is unfortunately, okay, it could be correct, but you could simplify it much more. And also, what is 5 to the power of 3? How did you get 15?
Oh, my bad.
And also your last power, y4.
Huh?
The y4. Y4 is incorrect. I'm just telling you.
Oh,
Hannah, that
I just like, oh, I simplified that side and I didn't simplify the other side.
is a fraction, you could simplify more, but in this case, oh, okay. Hannah, that is close. Yes, now it's correct. All right, Hannah, do question 10. Okay, Ryan, you can take a 2-minute break. All right, Ryan, it's time to come back. Your question 10 is not correct.
No!
Check which part is not correct. It's a tiny part, but yes, it's not correct. Oh, wait a second. Oh no, I'm choking. Your question 10 is correct. Damn.
Yeah,
Damn. Wow.
yeah.
Adriana, you could
Okay.
simplify it more, but that's not correct though. Your 5 should completely cancel out. All right, since everyone's on to question 9, I'll just explain this one. All right, Adriana, this is mainly for you, so please listen up. So we have, if we expand this, we get 25, or like 5 squared, right? We have two 5s multiplying each other, x2, y3, over 5, 3, x, 3 times 3, 12, y, oh sorry, 3 times 3, 9, y, 3 times 4, 12, right? Do you agree with me here?
Yeah.
All right. So first of all, we look at how the 5 cancels. Of course, this, my bad, my bad, my bad, my bad. This should be 5 cubed here. Sorry. Because this whole thing becomes 5 squared x squared. Yes?
Uh-huh.
So 5 squared and a 5, that's 5 cubed. And then x squared, y cubed, x squared, y cubed. Yes?
Yeah, okay.
Yeah, bottom part is just expanding. So 3, 9, and then 12, right?
Uh-huh.
Okay. And we can see that the 5 first, they completely cancel out, right?
Yeah.
And if we're trying to keep this as a fraction, 2 minus 9 is -7, or we have 7 on the bottom, right? And then
Yeah.
this is the same thing. 3 minus 12 is -9, or we can have 9 on the bottom. So in other words, we can also write this as x -7, y -9. Both answers are fine. Does that make sense?
Yeah.
Cool. All right, move on to question 10. Meantime, let me check. Hannah, you already got that one correct. Remember, I told you you got correct for 9. Move on to 10.
That is
Remember?
that
Yeah?
is for 10. What do you mean?
Oh, that is for 10.
No, but I didn't do it right.
Ah, okay, okay. Yeah, sorry. No, that looks so similar to 9. I thought it was 9. Okay, now. I can tell. Oh, wait, no, it's not correct. Unfortunately, none of the terms are correct. Try to do it step by step. Try to do it step by step. All right, Ryan, do 11 and 12.
Oh, okay.
Mhm. I just
So
don't
my
want you to like do nothing in the meantime. It's like, yeah.
I like doing nothing in the meantime.
Oh, up to you then. Up to you.
Nah, it's all good. I was scrolling Insta anyways.
Oh no.
Bro, have you seen the if students are inventors meme?
Nope.
Are
I
you
haven't been
serious?
scrolling for so long. Send it to me.
Okay.
I've been caught up in Italian brain rot for too long.
Oh, it's not even Italian brain rot, mate. It's like there was this motivational guy talking about how A students are the good boys who score work for me, like they're the perfect workers. B
Uh-huh.
students are the are the like managers. C students are like the person above that and stuff. Then the F students are the inventors. They're the ones who own the companies and stuff.
I see, I see.
Yeah,
Uh,
I sent it to you on Insta. You
yeah,
can
yeah,
check.
I'll have a look later. All right, let's look. Adriana, that is ooh, Adriana. Oh, Adriana, that might just be correct. I believe that is correct, Adriana. Hannah, that is unfortunately not correct.
Wait, Michael, for 11 are all sides equal in the square one?
Yep, for square, yes. The 6 is supposed to be the up sign. In that case, check your coefficient. It is not -9. All right, and then simplify. Ryan.
Or simplify. Okay.
Yeah. All right, I'm gonna explain 10. I believe Adriana got it correct. Hannah, you got a small mistake, but yeah. So listen up to this. So first of all, I like to separate the numbers like this, okay? And then you have x3 over x to the power of -8, right? So this is very weird. We have -8 on the bottom, right? You might think this is very weird, but you'll see how I'm gonna deal with that later. And then we have y9 over y11. So the first one is obviously -1 over 9. The second one, we can actually move this negative on top to become a positive power. The same thing as how we move a positive power on top, that becomes a negative power. The -8, we move it to the top, it becomes +8. Okay, and last one is y, 1 over y squared. Put it together, we have -x11 9y squared. And we can also write this without a fraction, doing something like this. Yeah, since we have 1 over 9, we already have a fraction here, but we can have x11, y -2. Adriana, is that what you have? I believe it is.
Yeah.
Yep, Hannah. Hannah, in that case, it is correct. All right, cool. I'm just letting Ryan do question 11, but it's pretty much the same thing. Extra practice for him, I guess.
Oh, I sent
Uh,
you question 11
yeah,
already.
yeah, that's correct. Okay, we're not gonna do that.
Wait, did I have to do 12?
No, no, I'm just finding something for you to do.
Oh.
All right, this is quite important. I'm gonna explain this. So square root, some of you might know, is the same as power to the half. It's quite interesting because we can represent a very disgusting thing like this as a power. Okay?
Mhm.
And the reason why is even more interesting. So first of all, let's just assume we have this power of a half. Okay? Power half times power half equal power 1 equal itself. Okay? And then we also have square root times square root equal itself. Yes?
Mhm.
So in that case, given that because we only know like okay, what I was gonna say, yeah, given that this and this they're positive, and them squaring each other, right? Like squaring themselves gives you x, right? Square root x square himself is also x. That means they must be the same. That means we have x half is just square root of x.
Okay.
Okay, so that's the reason behind this. All right, and then in the same way, sometimes we have cube root, right? Let's say cube root of x, right? cube root means what? For example, can anyone tell me what is the cube root? Oh, actually, what are you gonna say? What is it?
X to the power of 1/3.
Yes, exactly. Adriana, can you tell me what is the cube root of 27?
Like 15. Wait, I don't know.
What does cube root mean?
Like divided by
No. If it's divided by 3, I wouldn't say cube root. I would just say 27/3 equals 9. Right. Hannah, do you know?
3.
Yes. Why?
Because 3 times 3 times 3 is 27.
Yep. In other words, 3 cubed gives you 27. Then 3 is the cube root of 27. Adriana, do you get it?
yeah.
That's the definition. Okay. Same as square root. Because 2 squared is 4. So square root 4 is 2. It's the inverse of the power. And in general, we say it is the nth root, right? Nth root is the same as raising to the 1/n power. Okay, in this case, as Ryan said, the cube root of x is x to the power of 1/3. Interesting, right? And you can use the same way to prove it. X 1/3 to the power of 3 gives you x. Cube root to the power of 3. By definition, this gives you x as well. So they must be equal.
Mhm.
They must be equal in the sense that this is not a negative number, okay? Because sometimes -2 times -2 also gives you 4, right? But square root of 4 is only 2. But we also know 4 to the power of half, this is also 2. This is not -2, okay? So just gotta be careful. Just gotta be careful it's not negative, okay? Like it's part of the reasoning. It's part of the reasoning why this thing works. All right, any questions up to now? All right, then we move on to some questions. Oh, here it says, all right, yeah, this formula says m/n, but the problem with this formula is that it's not a pure formula. You could technically think about this as 1/n times m, right? So if we have a to the power of m/n, this is technically a 1/n times m, correct? Oh wait, no,
Mhm.
sorry, am to the power 1/n, right?
Yeah.
So you can split it up. Just leave out am. 1/n, you know, is the nth root. So am is here, and that's where this formula comes from. It's the combination between the root formula and also like and it's the combination between these two formulas. Are there any questions about everything? Okay, no questions. All right, move on to 9b. This is about the root. All right, let me see. Radical form. Okay, here radical form means, what does it mean? I actually have no idea, honestly, but I suppose it means no fraction power. No fraction power. Is there a proper definition for this? Yeah, it doesn't give you a proper definition for this, but it have an example. Radical form means no fractional power.
Okay.
It's a root and this power.
Yeah.
And then the other one is in exponential form. It means no. Okay, radical form means, sorry, it means no negative power and no no root. Oh wait, no fraction. Okay, so no fraction, no negative power. Okay, and the other one's opposite. The other one's opposite. Uh,
Mhm.
okay. That should be clear here. This means no fraction, no power, okay? No fraction, no fraction power. But you can have like, for example, here, instead of negative power, we're gonna be writing something like over x, over square root x, things like that, okay? Exponential is quite the opposite. So we want something like this. Let's say a to power of something, b to power of something, done, that's it. We don't want the square root sign. We don't want the fraction. No, we want to put it in one line. Okay. All right. So do the first 7 here right now. Send all the answer at once, please. And if there are any questions, please ask me.
Wait, Michael, for radical form, I thought it
Yeah.
was also no fraction.
No fraction power. See how it's having fraction power?
Oh yeah.
Yeah. But it's having negative power. So for example, in this case, when we have negative power, first of all, we wanna do something like this: 1 over 3x 3 over 2, and then go from there.
Oh.
Yeah.
Okay. Well, so how do you write square root?
SQRT bracket, or just if it's square root x, just SQRT x.
Wait, but what goes where?
You mean typing to me the answer?
Yeah.
Yeah, just if
Like if
it's
it was the square root of 2,
if it's square root 2, just say SQRT2
and then the number on the outside.
after SQRT. Doesn't matter you add a bracket or not.
Oh, what about the number on the outside? Like cube root.
Oh,
If it was cube root.
okay, that's a problem. Hmm. Hmm. Or you can just type it to me like third root of 3. I don't
Okay.
honestly actually have no idea. In that case, let's see which one do we need. We need the 5th root here. We need the 4th root here, and that's it. So
Okay.
okay, here's the thing. Okay, don't type it to me.
Can't you
Write
just
it on your.
copy and paste the square root? Like search it up and copy and paste it?
It's hard. It's too hard. Okay, here's the thing. Write it on your paper. Write it on your paper, and don't have to send it to me. If you have a question, ask. But once you finish, tell me you finish, and I'll go through the working. Does that sound good?
Mhm.
Okay, yeah, that sounds good. Because it's too hard to type to me. All right, guys, I'll be back in 2 minutes. Okay, I'm gonna go bathroom. All right, guys, how are we doing? Hmm. Wait, wait, can you guys hear me?
Yeah.
Okay, yeah. Which question you up to, Ryan?
The
C? I thought you'd be faster.
I'm I'm kind of choking.
Okay, it's okay. Yeah, you should have told me.
Oh no, I can see it now, but I'm just like halfway through C.
Sorry, just give me 1 second. I'm gonna get a whiteboard so you guys I can write the question down better. So just give me 1 second. I'm like, all right. I believe you guys should see the question on the whiteboard.
Mm-hmm.
Yeah, that's good. Okay, good.
Because
Yep, yep. Ask me if there's any questions.
wait, I think I got it.
Okay.
Do we have to
Adriana,
do
which one?
two as well?
No, just do one first. I'll explain one.
Okay.
Yep. Which one are you up to right now, Adriana?
I skipped F and then I did.
It's okay. All right, so F is not that hard as negative power. Okay, so we'll go through one by one. First of all, A is just square root 7. I believe everyone's fine with that. B, you kind of trying to split it up. You can you can bring this inside 3 and 1 over 5, right? Because 3 over 5 is 3 times 1 over 5, and that gives you 8 to the power of 1 over 5, and that is fifth root of 8. Is everyone okay with this?
Mm-hmm.
Anyone got this wrong?
No.
It's okay to get things wrong. I just want to know like the reasons behind it and then trying to help you guys. So yeah, if you got anything wrong, please like tell me and we can
Wait,
try to work it out.
I didn't do this, like I wrote it as, um,
Let's see. Ah, okay. Yeah, I mean, yeah, I guess that's fine as well. I think that's fine as well, but like write
that's
an 8
how
as
my
well.
teacher told me to do it.
Yeah, I think that's fine as well. As I said, as long as you're not having negative powers or fraction powers, then it's fine, I think. Yeah, and then 6, 3 over 2 is the same thing. I'm just gonna go to the answer straight away. Is square root 6 to the power 3, which is square root 216. But I believe Hannah, you did this. Yeah, I guess both are fine. This is not that important. Again, since you're not having negative power or fractional power. Okay. And then
Oh,
for
bro, that's
D,
it. Damn.
oh, what else do you think? You
I
can't
thought
square root this.
nah, because I genuinely
Hmm.
I was like doing square root 6 times square root 6 times square root 6 and stuff.
But the question problem is you actually. Oh, here's the thing. I guess you could try to simplify this more, right? Because 216, you could take out 6 out of it, so you could have 6, oh, square root 6.
Yeah,
You could
because
have this.
yeah.
Yeah, but if you, yeah, I get what you mean. And in that case, your answer would be this, which is still fine.
Mm-hmm.
Because technically okay, technically you could do something like this as well. 6/3 over 2 is the same as 6/1 plus, oh, sorry, times 6/2. Does this make sense to everyone?
Mm-hmm.
Adriana?
Yeah.
Okay, in that case, it's just 6 square root 6, right? So yeah, that's another way of doing it. And for D, what else do we have? For D, pretty much same thing. Fourth root of 2 power 5, which is, maybe I should go into more detail because I actually want you guys to remember this detail. So you could 2 power 5 and then take the fourth root, right? And then equal to 32 to the power of 1/4, which is fourth root of 32. And you may wonder if you can do anything about this to simplify. And technically, yes, you do the same thing, and then you could do something like this. So 2, 5 over 4. This is 2 times 2, 1 over 4. Okay? And that becomes 2 times fourth root of 2, which is quite simple as well. Maybe arguably more simple than this. Does that make sense to everyone?
Mm-hmm.
Yeah.
And similar to how the square root works, you know how we always have something like square root of AB. This is square root of A times square root of B. I always tell you guys about this. In this case, it's the same, right? Fourth root of 32, this actually equals to fourth root of 16 and then fourth root of 2. And the fourth root of 16 goes down to 2. Okay, that works as well for the same reason. For the same reason as the square root. And just a quick test on your knowledge. Can anyone explain to me, any of you explain to me why this is true?
Because they're both being square rooted.
Yeah, why are they equal? Why we can do this, or why both sides are equal? Yeah.
Because 1 over 2 AB and is square root A square root B or something. I don't know.
Okay, anyone wanna give it a try? Try to recall it, because I think I did tell all of you guys like in the private lesson why this is true. Anyone wanna give it a try?
They both give the same answers.
Something like that, but
Wait,
why are they the
is it
same?
because the oh wait, a squared times b squared is like wait, I don't think so.
But like you do remember I told you at some point, right? Okay, remember this. Like I mean, this is not that important to remember the rule behind it, but I guess it will help in terms of remembering this. So we want to prove both things are the same. Um, we can do something to both sides and then easily see that they are the same. So if we square both sides, this becomes AB times square root AB, right? So this is your left hand side, which equals to AB, of course, right? And right hand side becomes square root A times square root B times square root A times square root, oh, rough writing, square root A times square root B. Yes. And we can do some rearrange. That gives you square root A times square root A. I don't know why I'm writing a diagonal line, but yeah, excuse my diagonal. And that gives you A times B. So same implies square root AB equals square root A square root B. Does that make sense?
Yeah.
It looks kind of complicated, but all we did is squaring both sides and realize, oh, squaring both sides, they both will give you AB. And that means they are the same. Does that make sense to everyone?
Yeah.
Hannah?
Mhm.
And one thing we got to consider here that I didn't mention is we know both of them are positive because we know something like -3 squared also gives you 9 and 3 squared also gives you 9. So if you square them and they're the same, it means they could be equal or they could be positive, negative. But given the square roots are positive, then they must be equal. All right. When you square, when you're trying to prove something by squaring them, you always got to watch out the possibility of them being negative. Okay, that's something very important. All right, we up to D. Any questions up to D?
No.
All right, cool. E. Okay, E is slightly complicated, not too much. -1/2. First of all, negative power you put it below, so 5/2. And second of all, a half is square root 1/5. F. Oh, F is complicated.
Wait, Michael, before
Yep.
you give the answer,
Yep.
because I'm pretty sure I got this right, because I had like
Yeah.
an epiphany for this, bro.
Okay. Tell me what
I
did you get?
genuinely felt like I like cooked on this one.
Okay. Okay. You got cooked or you cooked?
I don't know. I might have gotten cooked. I'll just type it to you because I'm pretty sure I
No, you
hope
can say after you can say it if you want.
it's is it like -3 to square root 3x or -3 cube roots like
When you
3?
say -3, it feels weird because we don't have a negative here.
Yo, that is that not a negative?
Oh yeah, am I? Oh, sorry, it's a bracket, but no, we don't have a negative here. Okay, here's the thing. The negative sign only comes from anything that exists before, okay? Power will never give you negative. Even if it's a negative power, your result will not be negative. For
Oh,
example, for example, uh, 2 to the power of -1, what is this?
isn't it like 0 point something?
No, 1/2.
Oh, 0.5.
1 over, no, no, yeah, 0.5. Yes, but like I was expecting 1/2, and that is positive. And you never have a, okay, so if we have like very large number, let's say 1 billion, what do you get here? 1
Oh,
over 2 to the power of 1 million, right?
yeah.
That is a tiny number, very close to 0. But you never get 0 or you never get negative number when you're raising to a power. That's why the graph of exponential looks like this. This is your x, this is your y. Anything, let's say you have x to the power of, your graph is y equals x to the power of k, whatever power it is. Oh, sorry, no. K to the power of x, right?
Yep.
Anything to the power of x. The graph looks like this. It approaches x-axis, but never really gets to 0. So this is when you have like, let's say k to the power of 10. And let's say this is when you have k to the power of -10, right? But they always give you a value bigger than 0.
Okay.
Does that make sense?
Yeah, I get it. That
Anyone else has any questions? All right, in that case, yeah, that's why I said you can't have a negative sign in front. But otherwise, we do whatever is needed. So first of all, we see the negative power. We put it yoink it below, right? I believe Hannah, you got up to this step,
Yeah.
and that's good because that's correct, but that's not the final answer. It's mathematically correct, but you could do more with it because we said no fraction power. Okay. So in that case, you just do everything on the bottom instead of doing everything on the top, right? You break up the power. You'd be like, oh, this is 3x to the power of to the power of 3, and then to the power of the half, right? I know that looks disgusting, but yes, it is what it is. And then you get 1 over square root 3x to the power of 3. In that case, it's 27x cubed. Does that make sense to everyone?
Wait.
I could
Okay.
write an extra
Okay.
step. I could write an
What?
extra step. 3x 3. Yeah, what is it?
I thought we couldn't have powers, but never mind. It just can't be.
Oh, it just can't be fraction or negative.
Yeah.
Yeah. In this case, yeah, of course, it is not fraction or negative.
Mhm.
And I guess you could simplify this more by taking, or you could do something like this. As I said, you could do something like this.
Wait,
I
Michael, you
believe.
3 out, right?
Pardon?
Couldn't you take the 3 out?
You could even take the x out,
Oh, damn.
something like this. But and personally, because we're splitting up x, I don't like this that much. I would rather just go with this. And
Yeah.
yes, you could take the 3 out, something like 3 3 3 square root 3 x. Yes, square root x 3. Yeah, nah. Yeah, you could write it in the multiple ways, but I believe this is quite simple. And I get where you're coming from, because in the previous question, we did do something like this.
Yeah.
We did do something like this because it's a number. And in that case, that makes it much simpler, I believe, compared to this, compared to fourth root of 32. Is that, right?
Yeah.
Okay, that's F. Any questions about F?
No.
Adriana,
No.
did
Wait,
I
so
lose you
that
or
Well,
yeah?
I just like for my answer, I just got square bracket 3x to the like close bracket to the power of 3.
That 1 over? Do you have the 1 over?
Yeah. Was
Then
that okay? Can I just
I believe that's fine, but like maybe if you see this bracket, just expand it. It's not much effort. So you got this instead.
Yeah.
Yeah, I guess one more step won't hurt. And but you're on the right track, so it's okay. All right, and last one. Am I bothered? I can't even be bothered because it's the same. Yeah, this is pretty much the same. I can't be bothered with the last one.
Wait, did they give the same answer? But
Oh
yeah,
no, very similar questions. Similar questions.
yeah.
I just can't be, do you really want to know? I can quickly do it.
Nah, it's all good.
Okay, because I thought like you would know how to do it anyway. All right, so now everyone do question 2. In this case, we just want the answer to be in the form of something like this. Let's say like a to the power something, b to the power something, and we don't want fraction or negative power. No fraction. This is not fraction power. This is no fraction. Sorry, not no. We want negative power. No fraction and no fraction, not no fraction power. We want fraction power, but not a fraction. So we pretty much want this kind of stuff. Okay. No root sign. Okay. We want this kind of stuff. So we're just converting this to this back and forth. Okay. So try to do all the questions. In the meantime, when you guys finish all this question, we can take a break, and then after the break, we'll discuss the question. I think we'll come back at. I think I'll give you guys around 5 minutes. I think we'll come back at. Right now it's 5:07. So Sydney time will be 5:14. We'll take a 5 minute. Oh, you guys gonna do the question takes 5 minutes and then break. We'll come back at 1:08. Okay. And then for New Zealand time, we'll come back at 7:18. Okay. Yeah, do the question first, and then we'll have the break. So I'll still be here when you guys do the questions.
wait,
For any.
mister. Um,
Hmm?
what does
Yeah.
the 3 here mean? Like the first one?
Oh, this one's okay. This one means square root 10 to the power of 3, like this. I assume. I'm not 100% sure, but that is, yeah, that is very. Here's the thing. it doesn't matter if it's inside or outside. This is actually equal. Square root 10 to the power 3 equals square root 10 to the power 3. They're equal. Because
Oh.
this is just, you can have a look at this. This is just square root 3 to our half. This is just, sorry, square root 10. 10 to our half to the power of 3. So they both go to 10 to the power 2/3. I'm pretty much explaining the question here, I know. But do you get it?
Mm.
Yeah, since I already said it to Hannah, I'll just write it on the screen for you guys. Yeah, this is question 1. Oh, when you guys finish everything, please just type something in the chat. I want to know how fast it takes you guys to do it. Yeah, just tell me when you finish everything.
Wait. Oh, bro, I'm actually so blind.
How are you guys finding the difficulties? Is it all right?
Yep.
Hannah? Adriana, you reckon it's too hard or is it okay?
It's okay.
Okay, that's perfect then. That's perfect. Adriana, you're moving my picture.
I finished.
Whoops, sorry.
Michael, I finished.
Nice. Okay, you can take a 7-minute break. Or if you want more questions, I can give you more.
Nah, I'm good, mate.
Okay, that's good. All right, today the plan's gonna be like this. Initially I wasn't gonna get into logarithms, but since Hannah's doing logarithms, I will introduce logarithm to you guys. Maybe just the fundamentals and some techniques in the last 5 to 10 minutes of the lesson. Okay. And then
So can we have the break now? Or
yeah. If you finish, is a break. Do you
yeah.
finish?
Yeah.
Okay, sweet. Then 6-minute break. Sure. Hannah,
Yeah.
you finished?
Mm-hmm.
Okay, we're gonna make the break slightly shorter to 17 then. 5-minute break. 5-minute break. 17. All right. I'll be back later. Okay, hello guys. Are we back? Guys, type something or say something if you're here. We're gonna start again. Ryan? Okay, Adriana says she's trying to fix her internet. You can hear? Oh, okay, no, then it's probably not internet. It's probably because I gotta reshare again. I'm gonna share this again. If you can see, tell me if you can see me.
I'm back.
Okay, nice. That's just in time. All right, can everyone see the whiteboard?
Yeah.
Hannah? Okay, cool. That's good. All right, so you have got all your answers. Right now, let's just see if they are the same as mine. Okay, I'm gonna quickly do them all. Before I do any of them, are there any specific questions about anyone?
The last one.
Last one. Okay, G. So, oh, that's actually okay. So root x you convert it to a half, right?
Mhm.
And then you put it on top by making it negative. And that's it. Easy.
Yeah.
Okay. Anyone else has any questions?
Like wait, no. E.
E, okay. Let me just do F so we can have like this kind of in order. 3x a half. F is easy. E, oh yes, E is complicated. That looks disgusting. All right, do it slowly. Fourth root to the power of 5, so it's 2d. So fourth root to the power of 5 is 5/4, okay? That's the first step.
Yeah.
And then we put it on top, so 2d negative 5/4. If you want to, you can split it up, but I don't see a point. You could have 2 negative 5/4 times d negative 5/4, but I don't see a point in this. Okay,
Okay.
and technically it says no fraction, but number does not count as fraction. Okay, you just can't have fraction over the algebra. With the 2 negative half over 5, you could have something like 2 to the power 1/4 divided by 2. Wait, no, that's not how it works. No, it's 1 over 2 times. Technically, you could have something like this. So the fraction only applies to this, but yeah, this is dodgy. But leaving it like this is totally fine. Okay, yeah, ignore the dodgy stuff. All right, for C we have, oh, this is easy, 7/3. I guess I should write more details. So you could have the root convert to a third first, and then you multiply the power because of the formula. And I know I've said this many times, I just want to re-emphasize again. This formula is XAB, and the reason behind why this equals to, the reason behind why we can multiply the power is because we can treat this as a bunch of x multiplying each other. So we got ax multiplying each other. And if we treat this as a group, the B means we have B lots of this group. So that's in total A times BX multiplying each other. So the equation says this is this is x to the power of A times B. Okay. So I believe, is that okay with everyone?
Yeah.
Okay, cool. All right, what do we have? C, D, and we just have D now. D is, oh, D is okay. So again, we move the root to a half, okay? And then we put it on top. Done. Any questions? Anything that's different?
No.
All right, let's get back to the curriculum. All right, oh, what should we do next? Because that's pretty much the power rules. And here are some examples. We can do this practice, and then I don't know if we want to do exponentials, and then that's log. Mm. Ah, okay. Could be interesting. This could be interesting. So a lot of you wonder, what is the natural number e? Okay. So here, the natural base e, or just natural number e. E is approximately
Isn't it
2.71.
well,
Yeah, approximately that. Yes, nice. But you wonder where it comes from. We say it appears in nature, but it actually people say it's a scam. But whatever it is, it comes from math formulas. Okay, and it comes from this equation. This is the interest rate equation. So your one, you know how we calculate interest rate like this? Let's say you have $100, right? You multiply this by 1 plus your interest rate. Let's say your interest rate is 2%. The next year you're gonna have $102. Okay? This is pretty intuitive. Does this make sense to everyone?
yeah.
All right. But the problem is, let's say, what if your interest rate is paid um, every month rather than at the end of the year? In that case, bank kind of simplify stuff and be like, okay, um, we're gonna pay you slightly more and by calculating interest rate every month. Okay, so every month I will pay you R over 12. Okay, which is 12, 2 over 12, whatever it is. But I'm gonna pay you this 12 times, and the interest rate compounds. It's like, let's say I'm paying you something at the first month, and that something goes back to the investment and compounds. So we actually raise this power by 12. So I'm paying you this much, but 12 times, and each time there's more. So this is called compound interest rate. Does that make sense to everyone?
Yeah.
If not, I can explain this term in more detail. Hannah and Adriana.
Could you do it in more detail, please?
Okay, yeah, sure. So say if we get paid monthly, and something very important in finance is the rate, compound interest rate. Let's say if the first year we have 102, right? The second year we're gonna have 102 times 1 plus r, right? This is one. Oh, this is hard. 102 times 102, what is this? 104.02. Okay, I'm a genius. Wait, no, I'm not a genius. I think that's wrong. Or 104.04, I believe. Yeah, 104.04. So see, we're not gaining $2 extra, but instead we're gaining $2 extra and 4 cents. So this four cents is from the compound interest. Does that make sense to you on the second year?
Mm.
Adriana?
Yeah.
Okay. Okay, I can do a simple example. Let's say we make 10% profit. The first year it goes from 100 to 110, right? But then it doesn't go to 120. It goes to 10% of 110. The next year it becomes 121, right? We get the 121 from 110 times 1.1, right? We get this from 100 times 1.1, okay? And then it compounds. This is 1 to 1. This is 133.1, which is, where is it? Let me quickly calculate. Yeah, 133.1. And that comes from 121 times 1.1. So the thing I'm trying to emphasize here is that we're not gaining $10 every time. The money we gain depends on what we started with that year. So this compound is different from 100, 110, 120, 130. See, we're getting $3 more here. And this has huge potentials in 10-year, 30-year time. Does that make sense?
Mm.
And in that case, we could represent this number with 100 times 1.1 to the power of 3. So this is what we have in 3 years' time with 10% interest rate. Does that make sense? So people wonder, what if we compound at a faster rate? Let's say it's paid monthly. But in that case, our annual interest rate is fixed. Let's say it's R or whatever, right? But in that case, we can split up the interest rate in like say 12 months. So we pay like smaller amount, but each month. But this thing gets compounded every month. So each payment at the end of every month gets reinvested. And that payment also enjoys the interest rate of the next month. Does that make sense? Just like how we had the compound with the every year. Does that make sense?
Yeah.
Adriana?
Mhm.
So in that case, I could use an example here. So rather than having 1 plus 10%, which is 1.1 for every year, we could have 1 plus 1%, which is 1.01, but for 12, but for 10 months, but 10 times every year. Okay, 12 might be confusing, but 10 times every year, right? So instead of having, okay, Adriana, which one would you choose? Save your money in the bank with 10% paid at the end of the year, or with this paid every monthly and reinvested, so calculated using this. Which one would you pick?
Wait, what was the first one?
You either invest your money in the bank, $100 becomes 110 at the end of the year. So the interest rate is 10%. It's 1.1 times your original money. Or would you rather choose this? Your interest rate is paid monthly, or like in 10 times, but each time is 1/10 of whatever you're gonna have. But that 1/10 gets reinvested, which is calculated using this formula. Which
This
one would you pick?
the second one?
Why?
Because you get the interest rate every month. Or like, I'm not really sure.
So technically, this reinvestment process allows you to get some of this money early and get interest rate off those money. This is compounding. Does
Oh,
that make sense?
okay.
I could make it simpler. Let's say you double your money every year, right? But now I'm saying you get a chance to have a half of your profit early. Let's say half year in, you get $50 already. You could put that $50 back in, and then you're gonna get extra $25 at the end of the year. So rather than having 200, you now have 225. Does that make sense?
Yeah.
So the key is to get your money early and then reinvest while you're still on your plan. You can think about it. So this is the formula for that, and that gives you. Okay, I'm just gonna use calculator. Something bigger. It's 1.105 approximately. Okay. And now people wonder, okay, what if I just reinvest every day when the time interval becomes so small? And that's why this equation appears. We divide this interest rate into so many small pieces, but compound like infinitely. All right, now tell me, what if x is just 1? What if we're not compounding? What is this? Can anyone tell me?
Wait,
Right, can you
Ju-
repeat the question?
just filling in this table, the first bar.
2.
Okay, nice. So 1 plus 1 is 2, 2 to the power 1 is 2. All right, we're just doubling our money. But what if we compounding once? So we having, yeah, what is the second line?
wait, but this time we're compounding.
Just you can just look at this formula.
3.
9. Oh,
Oh wait, actually, I don't know.
Adriana, what did you say?
wait, can we calculate it?
Yes, but not calculator. Try to use your head.
Oh wait,
What
is it 2?
what is inside the bracket?
Oh,
1 plus 0.5.
Yes, what is that? 1.5. What is 1.5 squared? 2.25.
Yeah.
That's what I was talking about. Say if we doubling our money every year, but we get, okay, let's say we have 100. At the end of the year, we get double our money, 200, right? What if we get a payment in the middle? We'd be like, okay, we're doubling our money, so we get 50 in the middle, becomes 150, right? But here we are doubling our money, but not doubling the 100. We get the 50 plus the reinvestment, which is 150 times 1.5, which is 225. That's what I was talking about. If we get some of that investment back early, we can use that to further compound our result. That's where the 225 comes in. But if you don't get the finance perspective, you could just look at this formula and know that this means compounding in a shorter amount of time. Yeah, I don't think I explained this really well because I don't have
Wait,
that much time doing it.
the longer you compound, the more you get, right?
Yeah, but right now we're talking about fixed time interval, but more, okay, how would I say this? I think this is actually important. I might go into more detail with this. Yeah, I need to make sure you guys understand this because this concept is quite important. I'm gonna go into great details, so bear with me. You're gonna get it just in a second, okay? All right, let's say we, right now, what bank do we have? ANZ. This is a Australian New Zealand bank. They offer 10% return on 1 year investment. Okay, the $100 turns into 110, obviously, right?
Yeah.
Now we have a different plan. We'd be like, still 10% return, but paid quarterly. That means it's paid in 4 payments across the year. Does that make sense?
Is that like 10 over 4 then?
Yep. So you actually get, this means in terms of finance, it means you get paid 2.5. You get paid 2.5 each time. You get 102.5. And then you also get paid 2.5, right? And you get 105 plus 2.5, 107.5 plus 2.5, 110, right? Yes.
Mm-hmm.
But hang on a second. There's something off here. It's the same, but we know if we're getting this money early, right? The problem is, wait, we're getting this early. We get 2.5 early, so we can reinvest. Okay?
Mm-hmm.
So the next time it will not just be plus 2.5. It will be plus 2.5 and plus, what is the interest rate? 2.5%, right? 1.025 times the $2.5 we're having right now. So you'll be you having a little bit extra, right? Then in that case, we wouldn't want to calculate by adding. We want to calculate by multiplying. So let's say if we are every year we get 10% yearly, that means it will be 2.5% every quarter, right? Does that make sense to everyone?
Yep.
Adriana?
Mm-hmm.
So what I'm trying to emphasize here is that if we get paid the interest early, we could reinvest that interest and get more out of the everything. But if we don't get paid early, we only get paid $10 at the end. We couldn't do that. So these two give you different returns. Any questions? I haven't got to the calculation part, but that's the idea. Any questions about this idea?
No.
Ryan?
No, I'm good.
Adriana?
No.
All right, in that case, we will calculate by multiplying rather than adding. So quarter one, we're gonna have 100 times 1, 1 plus 2.5%, which is 100 times 1.025, which is 1025, or 102.5. Does that make sense?
Yep.
And then in quarter two, we can treat this as if we are starting the quarter two with this much money. So it'll be 102.5 times 1 plus 2.5. So we're having this fixed interest rate for every quarter, okay? You might be confused to be like, oh, why would the bank do this? Why would they offer you two plans where one is obviously better than another? This is a hypothetical situation. In the real world, there's a lot of variations with the finance stuff. So we're not going to dive into that, but this is a hypothetical situation, okay? But if there's anything confusing, always ask me. I probably 99.99% have the answer to, because I'm studying finance and math at the same time. Okay. So this gives you, oh, okay, I don't know what that is. This gives you 105.0625. See, we are getting a little bit extra than just 105. That's the catch. And then in quarter three, it'll be the same calculation. And in quarter four, it'll be the same calculation. But overall, it'll be 100 times times 1 plus 2.5% to the power 4. This is 4% 4 payments. Does that make sense to everyone?
Hmm.
That's where this power comes in. Adriana, what do you think?
Yeah. Hmm.
Okay, and remember this 2.5 comes from 10% over 4. Okay? And that would actually give you something just slightly more than 110. Okay? I'm just quickly calculating that now. That gives you 11038. Oh, wait a second. No, I screwed up.
Yo, Michael, can I leave early to eat dinner with my mom
Oh,
since
yeah, sure.
okay. Yeah.
I do that.
Bye-bye.
Huh?
Could I
Bye-bye.
eat dinner with my mom like in a couple of minutes?
Oh, in that case, I could just finish early if you guys want.
I don't mind.
Up to you guys. If you guys like actually have something, I mean, this is a kind of like a free lesson as well, right? So I'm really not really strict about everything. So, all right, let me just finish this first. So
Yeah.
you get a little bit more, right? And then people wonder, what if this number becomes very big? Let's say I get paid interest daily. Does it go to infinity? You could think, oh, this keeps growing. It might go to infinity. I get paid so rich, right? But in the end, it comes down to the natural number e. So if I say this is 1, right? I double my money. But what if I like get paid more frequently? It turns out, even with the 100% interest rate, the number wouldn't go beyond 2.71. It will approach 2.71. So the formula is like this. People wonder, what if we just keep on increasing this n here? What happened as n goes to infinity? Okay, that's the question that we were about to answer. So if we look at this, as we just did, this is 2.25. If we just do 10, see what happens. I'm gonna do it in my calculator. This is 2.59. And then if we make this if it's 100, we get 100 very close already. This is 2.77048. Eventually we get the natural number e, which is, it converges to this number, which is approximately 2.71828. Okay, something like that. So that's where this number comes from. Now, do you guys understand?
Yeah.
And the point of this number is for a lot of like calculation stuff. For you guys just have to know where this number comes from and know that it's a constant to do these type of questions here. Uh, 3 decimal place? No. Yeah, so this is very frequent, EX. Okay, this is very often. And then E negative EX and E negative X is just a number. It's just 2.71 to the power of X. You might think this is weird, but knowing that it's related to exponential, this makes more sense. So that's the whole point of the natural number E. Okay, and in this case, it's modeling growth of fungus, growth of bacteria, and it's using E because if we're thinking about bacteria growing, you can't really like they're growing on a macroscopic level infinitely fast, and that's why using exponential functions to model them is very appropriate. Okay, so we have E to the power of 0.3t. Normally with EX or like ET is just a variable, right? The 0.3 is pretty much saying that it's not that fast. It's like we're scaling it to model how it's actually growing. But you guys don't have to worry about that. That's just me giving you guys more context about this whole chapter. When you do the actual questions, the question is going to be very easy. They'd be like, find the initial area. You're just substituting t equals 0. Okay, Adriana, you don't have to worry about this right now because this is quite advanced. Even for
Mhm.
Hannah, I don't think are you guys doing this though? Hannah?
No.
Okay, but this is instead level. Okay, I'm just letting you know. This is just a function, be like, t is our time. This tells us how much bacteria, right? If it's asking what is the initial area, all you gotta do is substituting t equals 0. This is e to the power 1 at 0, which is 1. So this is the initial area, 4500. Okay,
Yeah.
you could also just use a calculator. And 10 days, after 10 days have passed, you just substitute t equal 10. Put in a calculator, see what you get. Okay.
Yeah.
But I believe if we do this now, I think it's a little bit too hard for you guys. And Adriana, you gotta go dinner, right?
Yeah.
What if we just call it a day here? And then what do you think? Hannah, do you have any questions about log?
Uh, well, there's one not here, but like there's one question on my sheet that I don't understand.
Okay. I think for the group lesson, we'll just call it there since Adriana gotta go. And then I'm gonna work out one extra question with Hannah. What do you think?
Okay.
Okay.
Thank you.
Yeah, I'll send. Yeah. What is it?
Thank you.
Yeah, all good. All right. See ya.
Bye.
All right, Hannah.
Wait, I'll send it to you.
Yeah. Finishing early today.
Pretty sure it's question B.
Mm-hmm. Okay, I'll just do one question because I'm kind of tired as well. Do you have
Yes.
more questions?
No,
I
it's
mean,
just
you can send it to me on WeChat. Oh, question B. Oh, inverse of 3. Okay. The previous question is irrelevant. The
yeah.
previous one.
Yeah.
This one. Okay. Where's the original line? Is this line the original line? Are you seeing the screen share?
Yeah.
This is the original line.
Mm-hmm.
Okay. First of all, domain should be smaller than or equal to 4. Is it not? This is 4, right? Can you hear me?
Yeah. Wait. Domain, I thought it was because it was F -1.
Oh, sorry, yes. See, sometimes I choke. Yeah, yeah. No, you're right. Yeah, you got to draw out. Yeah, sorry about that. Draw the inverse, which is a flip between this axis, and you drew it out, which is you can draw this like that. You flip over that axis, what do you get? Oh, maybe you drew the inverse wrong. Negative 4, 4 should be here, 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 and then to here. This should be your inverse. It's a reflection across this diagonal line. Okay, so this is not your inverse. Okay, this is not your inverse. Okay, but I think you still got it correct in terms
Wait,
of.
I didn't draw the inverse.
Ah, you're sketching these ones.
Yeah.
Oh, okay. Oh, sweet. Then yeah, I mean this is still correct. So after you draw the inverse, you're gonna be like, yeah, this is what it is, negative 4 and positive 3. Maybe I would write equal sign, but it really depends on whether it ends with a dot or ends with a circle. Okay,
Yeah. Wait, so circle without that's not filled in means doesn't include.
this is, yeah, and this is smaller equal to or bigger equal to. This is
Okay.
bigger. Okay.
Yeah.
Inverse of 3. This is no, this is no. Inverse of. Oh, wait a second. Yeah, no, but you don't write it like this. You just do this. This is you don't have this notation. This is very weird. You just do it one by one. You just be like f inverse of 3 one by one. This is negative 4, right? And then f inverse of 3. This is just f inverse of negative 4, right?
Wait, but I'm confused. How did you get to there?
Here. Oh, wait, 1 second, give me.
Wait.
So this is different notation, but same as this. These are the same thing.
Wait, so
Between
f negative 1 is
f inverse. Say f inverse. Don't say negative 1. F
f
inverse
inverse. What in the world is that?
is just a red line.
So it's x.
F inverse
Oh,
is
wait,
just
wait,
a
I think I
red
get
line.
it.
Yeah.
Oh, wait, no, I don't get it.
No, f inverse is just this red line. It's the inverse of the original function. It
So
takes
where do you
the
get 3 from?
3 is given.
Yeah, but how did you get negative 4 from that?
Okay, so agree with me right now. Red line is f inverse, right?
Mm-hmm.
And then 3 is here. So input 3 in, you get negative 4. That's applying it once. So this inside little bit is negative 4.
But how do you know it goes there?
By looking at the graph. I drew the graph according to this black line. Everything is from the graph in this case. You're not given any numbers. You're just looking at the graph.
Yeah,
That's
but
all.
nothing crosses over negative 4.
Oh no, this point here is on the line, right? This point here corresponds to 3 as the input and negative 4 as the output.
Wait, so what the hell is that red thing?
This one?
No, your red line that you drew.
Yeah, this is the entire graph. This means if it's 2.5 is here. If it's 1 is here. If it's negative 2 is 3.
But
1
what's
here.
the red line mean? Is what I'm trying to say. What is the red line?
Red line is the inverse function. It's the graph of the inverse function.
But I thought the inverse function was the diagonal dotted thing.
Oh, that's the reflection line. That's the line of reflection to get an inverse function. Okay, easy example. You have quadratics, right? Inverse is square root, right? Putting these two together, you realize it's a reflection across the diagonal line. And you draw this like in the minimal scale. Yes? We're not including the negative part because including that makes this not a function. So that's why we're not including that.
So how do you know to draw the red line? How do you draw it?
Oh, I literally took the reflection. So you look at this line segment. If you reflect it over here, it's here, right? Oh, sorry, it's here, right? So you go from 0, 2 to 2, 0, and then 4, -4 to -4, 4. So the straight line, these two correspond to each other, right?
Wait, so right now there's 3 different lines.
Yes, but the black one is the
Why?
original function. The
Yeah.
diagonal is the line of reflection for us to get the inverse function. We use those two to get the inverse function, which is the red line here.
So what's this black line that I drew?
Nothing, not relevant right now. Your lines right now is not relevant yet. I'm not considering those. You said it's for question 3, maybe. Maybe
Yeah.
it is. -x, that's reflection across y-axis.
Yeah.
Yes, this is not correct.
Yeah, I know. That's why I rubbed it out.
Yes, and this is correct for question C.
Yeah.
So this means reflection across y-axis. But right now we're not thinking about that. We're just looking at this inverse function. Okay.
So inverse function is just rotated a little bit.
It's not rotate. It's reflect. It's reflect across this line. It may look like rotate, but it's a reflection, always a reflection across this line. It's always this. It's the input output swapped. So it's the x-axis, y-axis swapped. Look at my camera, like
Mm.
this.
And how do you know where to start the, why doesn't it start from here? Why did it start from here?
Oh, 4, 4. This is 5, 4.
No.
Diagonal is the diagonal line.
Why doesn't the, yeah, why doesn't this thing start from there? Start from here.
Oh, it's the perfect diagonal line. So this graph right now is a rectangle. I'm saying it's the perfect diagonal line. Like this. Y-axis is not, it's not this. It's this. The graph is slightly rectangular because this is 5, this is 4. When's your test on functions? Or have
Um,
you, is this your test?
and it ends here. Wait, hold on, sorry. It ends here.
No, it ends at, this is not perfectly drawn to scale. It should end at -4, 4.
Okay, good.
Yeah, I can fix this. Because it was like a rough sketch, so it wasn't like perfectly accurate. This is y equal x. So this is, you want to reflect over this line. It's like flipping something over. And then once we got that function, we can hardcore solve this by looking at the graph.
Okay, so and then you change it so that x equals f. I mean x
Uh,
y.
yeah, right now x always means the input. Right now x just means the input for the inverse function since you already flipped the function. So you put 3 in there, you'd be like, oh, you get out 4. And then it requires you to do it again. So you take the output and put it in again. So you get -4. You put -4 in.
Oh, I don't think my teacher didn't teach us this.
Yeah, but like this is the proper way to do it. And then you
Okay,
put negative
and
4
then
in.
so
You get
okay,
you get
wait. Now this makes more sense.
so you put -4 in, and then you get out +4. You put -3 in, you get -4, and then you put -4 in, you get +4, which is exactly what this line is talking about.
So you do it 2 times.
Yep, which is what this means. If this notation confuses you, you can do this. They are the same thing.
and then f negative 1 makes it
F
positive.
inverse, F inverse,
Makes it positive.
F inverse. It has nothing to do with -1.
Yeah, okay, so it makes it positive.
It makes -4. No, it doesn't make it positive. We put -4 in again, and it happens that it corresponds to +4. See this point right here? The line goes through here. We just look at -4 and go up. Be like, what do we get? We get +4. It's like any graph. We look at the quadratics. Let's say we got 3 here. We go up. We got 9, right?
Okay, wait. So f negative 1, 3 equals -4.
The F inverse 3 is -4. Yes, say inverse. Good
Math
habit.
inverse 3.
Say no, F inverse. Just say inverse, not -1.
And then you do it twice.
Yep, do it again. Okay, I can give you an easier example. Let's say your F, okay, I gotta go after this, but yeah, maybe make sure you understand this. Let's say your F is just x squared. I'm asking you to be like, what is F of 2? Is F of 2 like this? What is this? What is F2?
What's the equation?
Oh, F equal x squared.
Oh, 4.
4. And then you do it again. What is F4?
16.
That's what it was saying. Except you don't have the equation. You just have the graph.
Mm.
You gotta use the graph to help you find the output. Let's say your graph is this, right? This is your graph. Your input is this. Just look at the graph. Be like, what is the output? Go up and then go left, right?
Wait, so it's the first one is f inverse 3 equals -4, and then the next one is f inverse 3.
Oh, no. The first one was just me splitting up. I wrote this in 2 separate parts. The first, I was just telling you f inverse of 3 is 4. And we are using that in the second one. I could just ignore this first line. I could just say f inverse of 3 equals f inverse of 4. So the first step was just this to this. That was the first step. I took it out and read an extra line.
Oh, okay.
And that equals f of. Oh, that equals just 4.
Okay.
All right, I really gotta go. But if there's any questions, ask me on WeChat. I can answer, or we can go through it next lesson.
Yeah.
All right, have fun. See you Thursday.
Yeah. Bye. Thank you.
All right, see ya.